Good afternoon, all. Here's an Allen Bradley catalog 1336F-B075. And you'll notice that I have two of the bus capacitors removed from this drive. Now let me show you the results of the explosion of those two bus capacitors. Here's one of the capacitors. Look at that. You can see where it's bulged out right there, where it was going to let the smoke out of that one. It's got a good bulge right there. And this is the one that looks the best. Let me show you the worst. Oh, you'll get a kick out of this. Now, how would you have liked to have been standing next to this drive when that capacitor exploded? Look at that. That is horrible. But what we're going to do, I've got the two bad capacitors removed. These four over here are still good. We're going to power up the drive and enable it, run it on a light bulb load. The light bulb's connected to U, V, and W. And we're going to make sure the rest of the drive is good. And then we're going to order those two bad bus capacitors and reinstall them in the drive. That'll take a little while before we get those capacitors in, but in the meantime we can see if this drive is still working. Now, I checked for short circuits of the power modules. They're good. There's an SCR firing board right here, and it fires an SCR bank that makes the DC bus. The IGBTs, U, V, and W, they're good. Let's get this out of here. Got a little bit of dirt down in there. We can get that lint out. And they're good. So the SCRs are good. The IGBTs that run the motor are good. And we'll see if we have any more problems. Right here, I'll put the hookups at the end of the video, but we have an L6 option board, and that takes 115 volts into the inputs of these enables and start and stop. I'm going to take a piece of cardboard before I put 115 on that board and separate that 115 from the SCR firing board so that 115 don't jump onto that board and destroy it, and then we have more work to do. So we're applying 115 volts AC single phase to the L6 option board. This right here is going to be our speed reference, and right now we're going to apply 380 volts AC three phase to L1, L2, and L3. So far, so good. Okay. The panel says we're stopped and at 0.00 hertz. We're going to enable, accelerating to minus 10 hertz, and you can see our light bulb bank has come on. There's U, V, and W, and they're all at the same intensity. That's a good sign right there. If we had a bad IGBT that wasn't firing correctly, it might be brighter than the rest of them. So here we go. We're going to increase the frequency with our external DC power supply. Let's see what the hertz is on the display. It says negative 27.91 hertz. It looks like the rest of this Allen Bradley 1336F is good. Everything is working. Nice. You want to see what UV and W looks like? Let's do it. Turn the frequency down. Stop the drive. I'll go get the Fluke oscilloscope set up over here and we'll look and see what UV and W looks like. There's U to V. Okay, let me turn the speed down. It's ramping down. Be a little less noisy, I think, if I could get right on those UVW terminals. I'm using a long clip lead for the scope probe and scope ground. Still ramping down at negative 10 hertz. It's at speed. Okay, that was U to V. Here's U to W. Let's give it some speed. Let's see where we're at on the display. There's negative 75 hertz, negative 80 hertz. Okay, we'll slow down. Decrease the voltage on the speed reference input. Ramping down, decelerating at negative 30 hertz right now. Okay, we're at negative 10 hertz. Now let's look at V to W. Let's give it some speed reference. Okay, you can see it ramping up. We're accelerating. There's negative 50 hertz. Negative 70. We're at negative 80 hertz at speed. They all look the same. That's a good sign. All right. Let's decelerate. And at negative 10 hertz, I'll stop the drive. There's negative 10. And we've stopped the drive. Well, you saw another way that drives fail. And electronics for that matter. Those two big bus capacitors, they must have They must have had a loud explosion when that one gave up the ghost, and if the drive probably hadn't tripped out, the second one with the bulges in it would have gone up too. I hope they had a fire extinguisher near this drive when it went up. Okay. Everyone, I really appreciate you coming over and seeing what we're doing next. Y'all's good folks. We'll see you next time. Evening all. It's dark outside. I hope I got enough light in this kitchen for us to see what we're doing here. But here is the 1336F-B075 input board, 115 volts AC only. So be very careful around these connections right here, because they're going to be a little bit up there in voltage. Up down here on 30, 28, 24, 30, and 19, I have hot 115 volts AC. The neutral goes to 29 COM, 25 COM, and 21 COM. That's your common. Now the start input to this L6 option board is on 19. The stop is on terminal 20. 19 is a normally open push button. 20 is a normally closed push button. Now 24, the reason I have 24 connected is because sometimes 24 is set up as the auxiliary fault, and so I just leave that hooked up. In our case, the auxiliary fault is on 28, and terminal 22, 23, 24, 26, 27 are unused. We saw that in the video. 28 is the auxiliary fault input. Down here on terminal 30, that's our enable. This is the L6 option board. Now, down here on the control board itself, terminal 2 is called pot wiper, and terminal 4 is called signal common. And from a variable external power supply source, I apply 0 to 10 volts on terminal 2 with ground on terminal 4. I have a little adjustable knob right there on that power supply where we can increase or decrease that voltage on pin 2, reference to pin 4. Up here on terminal board 1, we have R, S, and T, or otherwise known as L1, L2, and L3. Not the same as this one down here. Not the same. This one down here is 115 volts AC. This one over here is 400 to 480 volts AC, and I actually use 380 volts AC on RS and T, and that drive's still powered up good. Now the motor on U, V, and W, instead of using a motor in this case, I used a light bulb bank configured in delta. So U, V, and W is where you would connect your motor. There we go. That's your hookups. It's getting dark outside. I gotta run out back real quick and order the basil and chives. They're still holding on, even though it's gotten chilly out. And then I've got to do a little bit of cooking and some laundry, so we're gonna get out of here. Y'all enjoy your time with your families, and enjoy your time fixing things. Fixing things is quite a good skill to have if you can. Good night. We'll see you when the sun comes up.